Hey everybody, welcome. This is the study guide video, and let's go over it. So I filled out some of these before just so I could kind of go over them quickly, and I assume a lot of kids just check their work sometimes. But F, this first one's substitution because n equals 3, and we're literally just subbing in 3 for n, so that's kind of the big one. This one was kind of a typo because it had a -5 here. It should have been a +5, and then what we're doing is just multiplying 2 to both sides, so that's multiplication. This is an example of symmetric property. They're just flip-flopping spots. Here we're adding 1 to both sides. So that's addition property. This is our transitive property here because we have C there twice. We have AB and AB there. And then we also have D squared and D squared right here. And those pieces, show us that these two equal C, which means they should equal each other. Okay, sorry, I misplaced my highlighter. That's what I was trying to look for right there. So that's transitive property. 6y is going to be reflexive property. Here we're dividing both sides by -8, so division property. Here we're subtracting 1 from both sides, that's subtraction property. And then this one we're distributing the -3 through here, so that's distributive property. On the test, you're going to have one of these type of problems. Basically, you're just looking for a pattern. This is a great example of inductive reasoning, where you're just looking for a pattern. So this is kind of looks like it's 13, 18, 23, 28. So you're basically increasing it's from 10s to 20s to 30s, and then it's 3 and 8, 3 and 8. This one looks like it's dividing by 2 down. This is the power of 3s. So 1 to the power 3, 2 to the power 3, 3 to the power 3, 4 to the power 3, 5 to the power 3, 6 to the power 3. And this one's multiplying by 3 and probably a -3 as it's changing negative and positive. This is kind of making a triangle with a base 3 and height 3, so you just increase it by 4 and 5. Alright, so our first one is determine if this is law of syllogism or detachment. So for detachment, we want to make sure that the P matches up with our statement. And this one does. Under 6 minutes, 5 minutes 45 is under 6 minutes, so we can say, Alex will have a personal record. That's detachment. If these didn't match, we'd say no conclusion. So over here, we have 2 conditionals, so we're thinking syllogism. If someone's grumpy, P, they're not fun to be around. Q, if you're grumpy. See how it goes to P again? The pattern for syllogism has to be P, then Q, Q, then R. This does not follow the pattern, so it is a no-no, no-no. The next one does follow the pattern. Marathon, P. You're tired, Q. You're tired, Q again, because they're the same. You'll need a lot of rest, R. So then we can make the conclusion. If you run a marathon, you will be tired. So we are able to connect the P statement and the R statement together. Law of syllogism. If an animal is a puppy, then they love to chew furniture. Lucky loves to chew furniture. This should match the P statement, but it actually matches the Q statement, so that does not work. None. If 2 lines are parallel, they never intersect. If they never intersect, then they have the same slope. These are both the same Q, so this follows our pattern. So we can connect, again, 2 lines are parallel, then they will have the same slope. And I think I wrote that wrong. That's supposed to say same slope. Sorry about that, syllogism. Now this one I read at first incorrectly, so I want to go back and reread this. Beach towns are busy in the summer, so I'd rather write if a beach town, then busy. So always make it into a conditional first, and then I say San Clemente is a beach town. Well, since these match, then we can say San Clemente will be busy in the summer. So SC, busy in the summer, and we can all agree that that is true, and that is a law of detachment. All right, next, if you have a library card, then you can check out your books. So this is a conditional, right? So PQ. The inverse, we keep the same order, we just negate them. Negate. Okay? So if no library card, so the key here is no library card, then you can't check out a book. We didn't change the order, we just put no. And that is true. If you don't have a library card, you can't get a book. We'll make you get one. Converse, we take our conditional statement and we flip them. So the Q goes to the front. If you check out a book, there's the Q. Then you need a library card. There's the P. That is true. And then contrapositive, you flip them and negate them at the same time. So if you can't check out a book, then no library card. Okay. And that is actually true as well. All right. First thing on this one is you turn this into a conditional. If a driver, then 16 or older. Make sure you keep it in the same pattern. I put driver first because it was first in the sentence. Okay? So inverse is to say not to each of them, which that's false, right? If you're not a driver, you're not 16 or over. Well, that's, if you're not a driver, you could be 80 years old and you can't drive anymore. But you're definitely over 16. If you're 16 or older, then you're a driver. Again, you could be, what was I going to say? Oh, sorry. First of all, we flip these. So if you're 16 or older, then you're a driver. You could be 80 years old and you don't drive. And then we flip them and negate them. If you're not 16, then you're not a driver. That's true. You have to legally to be a driver, of course, over 16. And the counterexample of 26 is didn't get your driver's license. That could be another counterexample. You could be 18 and you just never got your driver's license, so you can't drive. All right, so if this, we didn't fill these out yet, so we'll do them quick. 1 and 2. 1 and 2 here are going to add to 90 degrees. So we're going to get 4x plus 13 plus 3x plus 14 equals 90. The reason why they add to 90 is there's a 90 here. This whole thing is 180, so these also need to be 90. So we get 7x plus 27 equals 90, 7x equals 63, x equals 9. What we're going to do then is plug that back into angle 2, and we're going to get 3 times 9 plus 14, which is going to give us our answer for angle 2 of 41. 1 and 3 are vertical angles, so they're congruent to each other. So 54 equals 5x minus 6. The funny thing is, I don't even have to solve for this because it says, what's angle 3? Well, angle 3 is going to be 54. I already know that because we said angle 1 and 3 are the same. So I didn't have to solve for x there, but we could solve it if we wanted to. 4 and 2 are also vertical, so angle 2 is 37 degrees. And then it says 1 and 2 form a linear pair. So this is not regarded to this problem. So linear pair means they add up to 180, so I get 18x minus 1 plus 23x plus 17 equals 180. We combine like terms, and we're going to get 16 plus, that's going to be 30, 41x equals 180. Subtract the 16, and we get 41x equals 180 minus 16, which is 164, and then divide by 14. And, 41. Yeah. Divide by 41. And we get 2 over 7. Let's just double check I didn't make a mistake. And 1 and 7, 16. Good. Okay, looks good. So yeah, 164 divided by 41. There we go. I typed it in wrong. So x equals 4. And then find angle 2, we just got to plug it back in. So that's 23 times 4 plus 17. And that should give me 109. Always double check your numbers. Should be good to go. On the back, to wrap this up, you use inductive reasoning for patterns. Use deductive reasoning for facts and statements. Okay, so inductive reasoning was this example up here, and deductive reasoning is kind of like our proofs. This is called a conjecture, but you don't really need to know that. I won't be testing you on that. All right, so algebraic, let's go. So here we're going to go ahead and subtract the 6x on both sides. So that's going to be subtraction property. I would recommend trying these first and then watching this, so don't just do it. From here to here, it looks like I'm adding 17 to both sides. From here to here, I'm dividing by 2, so division property. And then here, I'm just flipping them, so that's called symmetric. Okay, this next one here, we got to write it all in. So it's 8x minus 1 equals 5x minus 35. That's given. Okay, then we're going to distribute, so that's 8x minus 8 equals 5x minus 35, so distributive property. I like to get the x's on the same side, so I'm going to subtract 5x on both sides. So subtraction property of equality. I'm going to add the 8 over, so that's going to be 3x equals negative 27. So that's adding an 8 to both sides to make that go away. And then I'm going to divide by 3, x equals negative 9. That matches my proof, which is awesome. And that was division property. Okay, this one says draw a picture. I don't know what to draw when I read 2dt equals dr, but the proof statement says I'm going to show that t is the midpoint of dr. I can draw that. Here's dr, and t is the midpoint. So that's what my picture is probably going to look like. So we start out with 2dt equals dr. That's given. Then it says dt plus tr equals dr. That sounds like segment addition postulate. Next, it says 2dt equals dt plus tr. And I don't really know what that's from, so I'm going to try my highlighter trick because I kind of see that 2dt was there twice. I see that dt plus tr is there twice. And look at me, I'm very lucky today. Dr and dr is there twice, so that looks like green equals orange, yellow equals orange. They both equal orange, they equal each other. That's transitive property. And then here, it looks like from here to here, I'm subtracting a dt from both sides to get this. That's subtraction property. And then if they're equal, then this must be a midpoint, so that's definition of midpoint. And that's it. Okay, we'll see you guys. Bye.